a balanced chemical equation is it shows chemical formulas which have subscripts, so never any positive or negative charges, no superscripts. Those have been crossed over and down to have subscripts. And then there's coefficients to balance the numbers of atoms on both sides. You have the reactants on the left and the products on the right. Remember, those can be in any order as long as they're on the left side or on the right side. And then we're going to add physical states. And those are subscripts. That's the small lowered letter. And those are in parentheses that indicate the physical state of each compound in the reaction. So a gas, a liquid, a solid, and we're going to add what's called an aqueous solution. So this is something that is dissolved in water, and it looks like water. So water is the physical state L. And an aqueous solution is dissolved in water, and it looks like water, but you cannot see particles. You cannot see the particles anymore because they're dissolved in water. An aqueous solution is a substance that's dissolved in water. So this can be a compound that is an ionic compound, like what's shown here, NaCl. You have the sodium cations and the chloride anions. So this is an ionic compound. Or you can have just particles dissolved in water, which would be a covalent compound like sugar in water. So sugar is not an ionic compound, it's a covalent compound. Either way, the ionic compound or the covalent compound, when they dissolve in water, it is because of the property of being soluble. So this will look at different compounds have abilities to dissolve in water using solubility rules. And what happens when a compound dissolves in water is you can't see it anymore. So what you have here is a mixture of things that you can't see the parts, and that's a homogeneous mixture. So this is salt water at the molecular level. This is an ionic compound where you can't see the ions of the Na and Cl separated from the water molecules. At the macroscopic level, as you put the salt in the water, and then at the microscopic or submicroscopic level, the molecular level, what you have are ions of chlorine, so that's chloride, surrounded by water molecules, and you have ions of sodium, that's Na+, surrounded by water molecules. So a salt water solution is not NaCl as a solid using that physical state, but it's NaCl as an aqueous solution because it's dissolved in water and using this physical state AQ. So that's a subscript in parentheses. So those ions are separated, and in fact, when you have an aqueous solution, you don't have the compound NaCl where this is an ionic bond. In fact, the ions are separated where you have sodium ions, which you can indicate with the subscript AQ, separated in addition to, with the plus sign, the chloride ion, which you can indicate with the subscript AQ. What's shown in this molecular view are the interactions of the water molecules with the ions. And one thing to notice that the hydrogens of H2O are closer to the chloride compared to the oxygens of H2O are closer to the sodium. So this is positive to negative interactions, and positive to negative interactions are indicated